Hare Krishna. Hope you're doing well. Let's get started with this question on sufficiency, consistency, completeness, and as you can see, sampling distributions as well. This is the sample mean, and this is some version of the sample variance. Okay, let's get started. Now, we can we have to check whether the four options dealing with consistency of given estimators, completeness, and complete sufficiency, whether the claims are correct or not, which ones are correct. And looking at Tn and Sn, this is the sample mean, this is the sample variance. For the normal distribution, there's a very neat, maybe is not the right word, but there is a useful result which says that these two are independent. Actually, for the purpose of this, it's not even required. And we know that the sample mean will go converge in probability to the population mean theta, and this the sample variance will converge in probability to the population variance, which is also theta as per the question. And by Slutsky's theorem, if I recall correctly, if I'm incorrect, just let me know. We can see, because individually they are converging to, what do I say, theta, both. When we take Tn and Sn square, then this is going to theta, this is going to theta, so together they are going to theta square. Similarly, for Tn to the power 4, Sn to the power minus 4, this is going to what, theta to the power 4, and this is going to theta to the power, okay, it's already written, sorry. Theta to the power uh, minus 2. Actually, this is theta to the power minus 2, so this gives theta square. Both of these are correct. That's fine. That's done by Slutsky's theorem. Now, when we look at try to investigate the complete sufficiency of this, one thing that's going to be useful for us is the fact that normal distribution belongs to something called the exponential family of distributions. What exactly is that? I'll recommend you to take a detailed look offline. But essentially, we have this normal distribution PDF. X can take any real value. And based on the structure given, this can be expanded like this. Now, this is where the reason I put this in the pitfall section is because it may seem that we usually have a structure like this where x minus theta square, x minus mu square by sigma square, that is usually the structure in the PDF, right? So we may uh, sort of use the involvement of xi in sufficiency also, but when we actually expand it, we see that the x only function of x which is interacting with the parameter directly is this one, x square. And when we adjust it to have all the random variables together in the joint distribution, we will naturally get a summation xi square divided by theta. So this would be the only statistic touching the parameter or interacting with the parameter directly. So it is sufficient, and because normal distribution is in the exponential family, sufficiency and complete sufficiency will go together, and that is also solved. Again, the reason I put this in pitfall was because we may just look at this structure and think that okay, it is x that is interacting with the parameter theta. So when we scale it with the joint PDF, it is going to be summation xi or something like that. So that is why this is wrong. And another angle could be that we usually know that the sample mean is somehow very much connected to the population mean, and that may also give a doubt that why is summation xi square complete and sufficient. Maybe there's a summation xi angle as well, but when the structure is something like this, we should be rigorous, open it up and see what exactly is interacting with the parameter. And coming to, so these are correct, this is correct. Now whether this is complete or not, if we investigate the structure in the question, we see that when we expand this Sn square over here, that can be written as a function of summation xi square and summation xi by tn square. So essentially it can be written as a function of these two given over here, and we know that this is, the expectation of this is theta, and the expectation of this is, sorry, the expectation of this, uh, actually when the denominator is n minus 1, then it would have had been theta, but because of the denominator being n, this factor. Anyway, the point is both of them are very much, the expectation is of the order theta. So this is where the intuition should kick in, that these two, this and this, if taken appropriately together in a subtraction form, they should cancel each other out and give a zero. And that is how intuitively we can proceed towards the fact that it is actually not complete, because completeness means whatever function of this you take where, with the expectation going to zero, then the function itself has to be a complete zero. But here again, as I said, that this is theta and this is also of the order theta, we can take an adjustment like this where it becomes theta minus theta at 0. The expectation of this thing is 0, but note that this thing in itself is not necessarily always 0. So this is why we have a contradiction. And a function, essentially, this is the function based on these two inputs, where the expectation is 0 but the function is not necessarily always 0. So there's a contradiction and this is not complete. So looking at the question and the nuances often gives us hints to the counter examples that we need. Because what else you'll do, you see something and see something which is very similar, just cancel both of them out and get a zero. Take care. Hare Krishna.